Hello, welcome back. So in this video, we'll learn to create a data frame, explore it, add and remove columns, and access any row or column we want. Import Pandas as PD, Shift, Enter, runs it, and adds a new cell. So last video was all about series, one column of data. Today we build the full table. A data frame is just multiple series lined up side by side, sharing the same index. So let's start with the most common way to create a data frame from a dictionary, same like we saw with the series, but now each key is a column name and each value is a list of data for that column. So let's start building one. Crew data. Name. And then a list with names. Soro. Nami. Oops. Usopp. Comma. Sanji the cook. So now this is the first key value pair. Next one, let's do row, for example. And then, whoa, autocomplete. Let's take advantage of the autocomplete. Captain, swordsman, navigator, sniper, cook. And in order for this to be a proper table, each list has to have the same number of items. In this case, 5. So next, let's go with bounty. Autocomplete. Do your magic. No. So let's go with 30. Million. And then what I'll do is this. Copy and then let's copy including the comma. Copy. 1, 2, 3. Is that 5? 1, 2, 3, 4, 5. The last one, no comma. And then we will just change this to a 6. Change this to 16. 30. 77 million berries. Has devil fruit. Autocomplete. Yes, no, no, no. No, it's everyone is false. Let's change all this to booleans. True, comma, and then false, comma, and then all of them are false, right? Only Luffy has devil fruit. I think. Age. 17, 19, 18, I don't know if these are accurate. All right, let's run this. Green arrow, so I think we're good. Let's print our crew data. Okay, this is it's just a Python dictionary. So let's first convert it to a Pandas data frame. So crew is equal to pandas dot data frame of crew data, and we print the crew, and here we go. So here's our table, 5 rows, 5 columns. The index on the left, 0 through 4, was added automatically by Pandas. A few things worth pointing out. Every column has a name. Those came directly from our dictionary keys. And every column has a data type. Text columns store strings. Number columns store integers. Hasable fruit stores booleans. And every row has an index number. By default, it starts with by 0 and 1, 2, 3, etc. We can change that. So let's try that. Let's set the crew member name as they are, for now they are unique, so we can use it. So let's set the crew member names as the index instead. Let's go crew set index. No, crew dot set index, and then it takes a column name. So the column name for the column we want is name. And then let's see it in the nice format Google Colab gives us. Run this. So now, as you can see, the name column is a little bit special because it's not only a column with the names, it is also our index. For now, let's reset it back. So crew is equal to crew dot reset index, and this takes parentheses. Now let's see it. Let's run this, and here we go. We have our automatic index column, and our name column, our name series is just that. So as with the series, there is also a handful of useful things we can do to check out the data frame. For example, print crew.shape. In this case, 5 by 5. We get a tuple, rows and columns. So another one, print crew.columns. So we get a list of all our column names. This is useful, so when we import a data frame and we want to check out how many columns and it has. So another useful one, print crew the dtypes, data types. As you can see here, each column, we get each column and its data type. Object means string in Pandas. Int 64 is a whole number. So bool is true or false. Another useful one for when our data frame is too big, we can head. So we can explore, let's say, 3 rows or 10, for example, but in this case, our table is only 5, right? And its counterpart, crew.tail. And now we see the bottom part of our data frame. Another very useful one is crew.info. A full summary, shape, column names, types, and how many non-null values are in each column. So this could be like the go-to function to run when we import a table, or it's a very useful one. We see the column names, how many rows, how many non-nulls, etc. Okay, let's now do crew.describe. And gives us statistics for every numeric column. So it outputted only 2 because these are the numeric ones. It gives us count, mean, max, quartiles, standard deviation. The string and boolean columns are skipped because we can't calculate this stuff with them. Okay, so how do we access specific columns or specific parts of our data frame? Let's start with columns and with a single column with bracket notation. So crew and then bracket and bounty, for example. And we get back a series. A data frame column is a series. So notice the name at the bottom, bounty at the top, sorry. So this is the column name. And also gives us what data type. There is also dot notation like this, crew dot bounty. And we get the same thing. But dot notation, it's a shortcut, it's faster to type, but it only works when the column name has no spaces and doesn't clash with the Pandas method name. So bracket notation, I think it's a little bit more robust. And of course we could assign this to a name. My series is equal to this, and then my series.info class Pandas core series 5 non-null data type memory usage. So This returns a series, and now I can assign that series to another name, right? Okay. So back at accessing data from our data frame. So how do we access or get a subset of multiple columns? So crew bracket notation. So now it takes in a list name, comma, bounty. So this returns a data frame with 2 columns. So important, double brackets. The outer ones are the indexing operator we saw over here, this bracket notation. And the inner ones are so we create a Python list. And the Python list is of column names. And what we get back is a data frame because we are selecting multiple columns. So this is a very common pattern. So now we will take a look at how we access rows with the locate and index locate, like we saw with the series. Let's try it. So let's crew dot integer locate. And if I hover over it, like this, if I hover, index or slice expression. Okay, so we will just do this. So this is interesting. If we ask for the row at index 0, iloc returns a series with the column names. The column names became the index of that series and the values. So if this returns a series and these are the indexes, can we go like this, for example? Sure we can. Okay, back at the lesson. So now let's slice. Let's crew dot index locate, and here 0 to, not including, up to 3 but not including it. So we should get 0, 1 and 2. Let's run it. There we go, 0, 1 and 2. So now it gave us back a data frame. Now let's try it with not iloc, just with locate by name. Crew dot locate and then 0 to 3. Now looks the same, but this is different because now these are not the index slicing from number 0 to 3. This is telling it from when it is named 0 up to when it's named 3. So it includes it. I know, counterintuitive. I wish they fixed it, but hey, that's what we get. But the useful thing about this locate is that we can, for example, if we were to just one column here with the iloc, we will need to count 1, 2, 3, 0, 1, 2, like 2. And we get this one. And with the locate, we locate by name. So we go like this, comma, and then bounty. And if we want multiple columns, like we saw already, similar to, we crew.locate, and then we do that 0 up to 3, including 3 because it's locate, comma, and this is the row and these are the columns. But now we want multiple, so we pass in a list name, comma, bounty, and we get back a data frame. Of course, we could assign it to my new super data frame is equal to this, and then we print my new super data frame. Boom. So now let's do a little adding and removing columns examples, because this is almost needed every time. So the syntax is simple. We just assign a new column name like we would a dictionary key. Let's do crew, and we will include some math for this example. Bounty in millions, and then this is gonna be equal to crew, and then crew bounty. So this will return a series, and then this series we're gonna divide it by 1 million. 1 million berries, and then what these returns will be assigned to a new column on our crew. So how do you prefer, when I print or when I just display it? I kind of prefer the print because it's a simpler text format. But anyways, here we go. Here is our new column, bounty in millions. So let's do another little example now, using some little magical functions built into Pandas that we can always search for them. So what happens if we want to assign a Boolean, like a flag, depending on the values of a column? So we're gonna create a column is fighter, and this will depend crew role dot is in, and this is a little magic, whether each element in the data frame is contained in values. So needs parentheses because it's a function, sorry, and takes a list of values. Captain, swordsman, or let's go with cook. All of them are fighters, right? But we'll go with this for the example. Let's run this. No errors. crew. So here we go. New column is fighter with a boolean true or false. So this is in checks whether each value in the column is in the list we provide and returns true or false for each row. So in this example, Luffy, Zoro, and Sanji got true. Nami, Usopp got false. Even though maybe Usopp is the greatest fighter of them all. Is he? Nah, just kidding. Okay. All kidding stuff aside, very useful. Crew is equal to crew, comma, drop columns equal record notation, and then just bounty in millions. Cool. And here we go. We just dropped a column from our crew data frame. This is important. Notice we used a crew equals crew this to reassign, because when we use this drop, this returns a new data frame. So then this new data frame, we need to reassign it to this variable. Because if we don't do this, like for example, like if we do this, let's run all. Crew drop gives us a data frame without this column. But then if we see what crew has, crew is the original data frame who still has this column. This returns a new one. So then we assign this one and here we go. There is a little, sometimes when I look at tutorials and examples and things, they sometimes within this parenthesis do another parameter like in place equals true. So just like, so we know what this in place equals true means. This means do the whole reassigning thing by yourself. Oops. What happened? Let's run from the top. Yeah, because our crew, because we had run there already, it did not have the bounty in millions. So again, if we skip the reassigning and place the in place equals true, if we just do this line, it auto modifies the original. But I find it cleaner and easier to read like this. Okay, let's scroll up and do a little recap of what we did. So we created a data frame from a dictionary. Then we set the index, this column to index. Then we reset the index. Then we looked we explored what these little methods or attributes of our data frame do, like shape, columns, data types. These functions like head, tail, info, describe. Then we saw how to access columns, a single one of them that returns a series. How to access multiple columns that return a new data frame. How to access just one row that returns a series with the column names as the index and the column data, the values of each row. Then we saw how to access multiple rows using integer locate, how to access multiple rows and specifying a single column with locate, the same but multiple columns. Then we saw how to add columns using math, using booleans. And then we deleted one column from our data frame. So in the next video, we will load data from CSV files, Excel files, and maybe a URL. So no more building data frames by hand. We will bring them from a real data we might have. So that's it for this video. Thanks a lot for watching. Hope you enjoyed it. See you on the next one.